All right, well, I've got time. Good afternoon, everyone. Congratulations, you have made it to the end of this year's All Things Open. I hope you all have enjoyed this version of the conference as much as I have this year. I've been told that there's some lighting challenges with dark mode in here, so if you want to follow along potentially on your own device, I uploaded a PDF copy of my slides to that URL. We'll talk about things going. I'll leave that there for a second for folks to grab that if they want it. We got a little bit of configuration code and some other things that I'm a dark mode person, so I got some screenshots with that in it. So that'll hopefully help you be able to see exactly what I'm trying to talk about as we go through the slides. So a little bit of housekeeping to begin with. This talk is not a Kubernetes masterclass because, dear friends, I am not a Kubernetes master. I'm still learning. This is some of my experiences in running my own Kubernetes cluster in my house. This is also not a step-by-step how-to. We're not going to type everything into command line and wind up with a fully functioning GitOps system at the end of this. It is, however, an introduction to the idea of GitOps and infrastructure as code to run your Kubernetes clusters and deploy workloads and such. We'll talk about some software engineering processes. I'll get to this in a minute, but I hail from a long-time software engineering background, and some of the things that we have learned and put into practice for running our teams, how can we apply that to the GitOps idea of managing your Kubernetes clusters to make you more efficient and be able to deploy faster and more safely. We'll talk a little bit about some tooling. Won't get too far into that, but I do want to introduce it to tell you kind of how the one particular toolkit that I use and a couple other options, how they work at a high level, and give you an idea of what's possible when you get into the GitOps way of doing things. And then hopefully it's at the end, it's thought-provoking so that you come away from this and going, I like the idea of GitOps. How can we use that in our particular organization? And what can we do? What research do we need to do to be able to get from where we are to potentially using a GitOps-based method for managing your Kubernetes clusters? I'm one bullet behind. Sorry, I'm looking at the wrong slide. So a little bit obligatory. Who am I? There's also a blog post at that URL that has the link to these slides as well if you missed that earlier. You can find me on LinkedIn. I am a longtime software engineer turned manager, which some of you are cringing at the moment. Why is this guy giving a tech talk or a technical talk? Well, I'll get to that in a minute. Why? I'm also a veteran of the U.S. Air Force and the Air National Guard system. I'm a lifelong geek, right? Which is why I'm bullet number one. That's why I'm giving this talk. I'm an absolute geek. It started when my dad bought our first Commodore 64 way back in ancient days when we walked to school in the snow uphill both ways, you know. So some of y'all will get that reference. I also love automating things. I have been known to write CI pipelines for fun. And there's some people cringing at that too. You're right, exactly. It's a problem to solve, and I love doing those kinds of things. I love automating things, including, if you ask my wife, to the detriment of our house with the never finished home automation system. There's all kinds of things that are always coming out that I'm trying to integrate, and so the automation bit really appeals to me, and that's what brought me to the GitOps way of doing things and why I like it so much. I'm very interested in self-hosting for the last few years. I actually have a Kubernetes cluster running in my basement that you can see a screenshot of my. So if you actually go to that blog post, you're trespassing and coming into my house to a hard drive to get to my blog entry. So just so you know, be careful. So having said all that, GitOps, what is that? And why should you care? Initially, if I had to boil it down to one bullet, I would say that GitOps is the next iteration or next evolution of automation we all are familiar with DevOps. We've been doing DevOps, so to speak, for a decade plus now at this point. And DevOps allowed us to automate a bunch of things and allow different groups to work together to release things more quickly, to move faster. So DevOps was transformational when the idea came out and people really started to lean into it. In my opinion, GitOps is just as transformational from the automation side, and we'll look at some of that here in a bit. It also gives you much more consistency and repeatability in how you deploy things to your Kubernetes clusters. No more, oops, I forgot the one command that I'm supposed to do, and now I've borked the entire cluster. We get a consistent deployment and a repeatable deployment so that we can manage, in some organizations' cases, hundreds of clusters the same way and with consistent results. Because we have all of our configuration data in, I'll say one place. Now there's a caveat to that we'll come to in a bit, but it could be one source of truth or many one sources of truth, and I'll explain that on a slide a little bit later. We get away from the idea of having a lot of this configuration buried in individual automation, CI pipelines and things like that, scattered all over a bunch of different environments potentially. It's really hard sometimes to figure out why something didn't deploy correctly when everything is spread out all over the place and you have to go look at 27 different tools to figure out what happened. It also gives us a very transparent history because of the way Git works, and we'll get into this a little bit later. Every commit that we push has somebody's name attached to it, and potentially approvals, and depending on how you set things up. So you can actually walk back and see exactly what changed with your cluster's configuration by looking at the history of the Git repo. Not natively if you're using Git only, but if you're using some additional toolkits that we'll talk about, hosting and whatnot, like GitHub or GitLab, you can also then start building in a peer review cycle so that not one of your infrastructure engineers can just push something without having it reviewed by potentially more senior folks or folks that are more involved in that particular area of your cluster, so to speak. You can start getting some more eyes on the changes that are happening to your clusters and catch bugs and misconfigurations and things faster. I tell my team that we individually, not one of us has all of the good ideas, and we don't know everything ourselves. That together as a team, collaborating with each other, we have more good ideas and more information. We can help and learn from each other. And we'll talk about that on a little bit deeper note in a future slide. You can also then start to set up approval workflows so that that same rogue engineer over here can't just push something and it goes all the way to production without somebody approving it. And you can get as granular or not as you want to, depending on your organizational needs. And we'll look at that as well. Lastly, Git gives you the ability to very easily roll back a bad change. In software engineering world, when somebody asks something, that it didn't matter. The answer is always, it depends, right? But depending on the change, it can be as easy as one line of a command, or it's a lot easier than going back and tracing through a bunch of disparate CI pipelines to try to figure out what happened and reverse what happened in all of those if you store all of your configuration in Git. So now we kind of know a few bullet points about why we're doing things the GitOps way. Let's talk a little bit about deploying those changes, and we'll get to how we store that configuration. But I want to give you a little bit of an overview of one of the tools, and the one that I personally use in my cluster. It's a tool called Flux. And when I said that, half of you thought of this, and no, that's not that Flux. It's something different. So Flux is part of the GitOps toolkit. It is a system that essentially automates synchronizing your desired configuration that is in your Git repo and your config files with the configuration that's in the cluster itself. So essentially, it looks at what do I have in my cluster, what's in the configuration and what are the differences and what do I need to patch to make one match the other. It does not cover build and test at all. That's totally on you. It is solely focused on making sure that the cluster state equals the state in the configuration. And it does this by looking at the the next slide we'll see a block diagram kinda. It does this by looking at your config files and comparing them with the resources deployed into your Kubernetes cluster and figuring out, again, what to patch and what to changes to make it match. So Flux, I mentioned, is one of the toolkits. There's a couple of other alternatives. You might have heard of Argo CD. Argo CD is sometimes referred to as Flux's bigger brother. I'm not sure that's totally the case, but I've heard it described that way. There's some slight differences in how it operates, but most of what we're talking about here can be applied there as well. And the other alternative is Jenkins X. And again, most of what we're talking about, you can apply to Jenkins X as well, except for the fact, the one caveat is Jenkins X actually does handle the build process for you. I'm not going to get into either of those because I'm not running those on my cluster and I don't know as much about those. So this is a little bit of an eye chart, but I want to kind of take you through a couple of the different high-level pieces of Flux and kind of how this works. So if you look at the top left, the little person diagram, and if you could read that text on that line, it says Flux Bootstrap. So that is basically you setting up like a fresh, brand new Kubernetes cluster to tell Flux, hey, watch this source, and we'll talk about those on the right side in a minute. Watch this source for changes and then make it happen in short speak. So once you do that, then the source controller inside of Flux monitors whatever source that you have given it, along with whatever params it needs to connect securely to it and other params, so that I think by default it's every 15 minutes it does a check. And so if you push new configuration to your Git repo, which is what we're going to be talking about in the middle of those three icons, the center one. If you push new configurations, every 15 minutes at the longest, it'll do a reconciliation and apply your changes. There's ways you can speed that up if you're like me and you're impatient, but you can go read about those later. So the source controller then talks to the customized controller, and that really just then sets up a bunch of manifests to be able to know how to patch things into your Kubernetes cluster. That could be, like I said in the diagram, RBAC policies. It could be volumes. It could be persistent volumes, whatever. It figures out what patches need to be applied outside of the Helm controller that does its specific thing that the source controller already talks to as well. So if it finds any Helm charts in your config that need to be deployed, it hands that off to the Helm controller, and it handles spinning up those resources and those services and namespaces and whatever else is required for that particular chart. And then you have the notification controller that can be wired into more than Slack, I promise, but that's the example that's here on the, this is from the official documentation that I'll have a link to at the end of the slide. And so, but just to kind of give you an overview, on the right side, the sources that are set up there, you can see Docker and S3 buckets, and Git is the icon in the middle. We're going to be talking about Git, obviously. The title of the talk is not S3 bucket ops, it's GitOps, so that's where we're going to go with it. So now that we know a little bit about what Flux is doing and where it's looking for changes, you might think, okay, fine. I know I have to have a Git repo and I have Flux. What do I put in the Git repo? And where do I put it, almost as importantly? So let's look at kind of some ways that you can organize your source code inside that Git repo to get what you want out of Flux and its reconciliation process. Nearly everyone starts a very simple example. We talk about some bootstrap, which is that is used on that initial command that we saw on the previous screen. And then one folder per application that you want to deploy. And this is amazing for learning, experimenting, testing, playing, doing whatever. This will not scale. So you will very quickly, unless you're just doing something local with Minikube on your local machine or something like that, you will not stay with this particular way of organizing things for very long. As you might imagine, if you think about your particular organization and how many different apps and various things that you want to deploy into your clusters, you can imagine how many folders would be in that list at the root level of the repo, and finding what you want would be a royal pain. So moving beyond that, kind of the next logical step that organizations move to is a monorepo where we have kind of a folder per environment. And I apologize if that screenshot is small, but you can kind of see in there where we have some base configs, and then we have a dev environment with some apps under it. We have a production environment with apps under it, et cetera. And we have some cluster information and like general infrastructure as well. If you, assuming you can read it on the screen, you might notice that there's a GoToSocial under dev, a GoToSocial folder under dev that doesn't exist in production or staging. So that's an indication that, hey, we're working on this, we're testing it in dev, it's not ready to be in the other environments yet. And then when it is ready, then you would basically copy it, that folder, to the next environment where you want to deploy to. So this is really good for small and mid-sized teams that aren't maybe managing a ton of, like a super complicated cluster. Maybe it's your own team's cluster that you're working within. It becomes really easy for teams to really grok what's going on because they can see all the config in one place. It's all right there. You know, by looking at the production folder, what's deployed to production. You can see exactly how it's configured, et cetera. So there's another concept that we're going to talk about in a couple of slides called code owners. And that essentially then, setting that up gives you the ability to limit who has to approve changes in what various parts of the repo, so that you can say, nobody's going to copy something straight from dev to production without having an approval. And those that are set up to approve the production changes, they would probably say, no, that needs to go through staging first before it goes to production. So we're going to reject that. One caveat is that your performance of your reconciliation through the Flux engine will suffer as you start putting more and more things in here. It's not as bad as a one repo or one folder per application, because your clusters are only looking at a portion, the dev and whatever other parts on their clusters and things. But if you get to hundreds of apps, eventually it's still going to start slowing down, because you're going to wind up timing out your reconciliation before it is supposed to run again. And that's a TM, that's a bad thing. Moving beyond that, most large cluster management organizations that are managing a large number of clusters, they'll move to where they have a separate Git repo per environment. And so what that gives you the ability to do then is, from a permission standpoint, you can then further restrict. You don't have to worry about restricting at the folder level. You can restrict at the repo level. And then if it makes sense, based on if you have a massive infrastructure organization, you can then also additionally restrict at the folder level within that. But it gives you another way that you can set up your permissions for who can change what and the approvals that are required to push that through from one environment to the next. Speaking of one environment to the next, promoting changes between environments gets a little bit more complicated. Because before, we were just copying things from one folder for the dev environment to the staging environment. Now we have to move that configuration from the dev repo to the staging repo. And there's no real tooling that's built into Flux to do that. That's kind of on you to figure out. That can be CI scripts. It can be whatever makes sense in your particular organization's automation scheme. But that's on you to figure out the best practices for how your organization works to make that happen. The really good part about this is that we're able to, with this scheme, we are able to scale to many dozens or hundreds of clusters, and you can apply these configurations consistently and at scale and at speed, because we are now, the repos are much smaller and focused on the individual environments. A couple of like alternatives to this is you might also have, instead of a repo per environment, you might have a repo per team, or you could have a repo for app. This particular diagram still covers, the same ideas go before that. It's just a little different way that you wire things together. So I mentioned software engineering is my background, and some of the best practices that we have learned in tooling to do our jobs over the course of the previous decades. Let's talk a little bit about how we apply some of that towards managing our configurations as an infrastructure as code using Git. So a couple of bullets here that are kind of some advantages. One of the things that Git natively gives us is the ability to distribute updates amongst individuals and teams. So we can have, like, literally, I didn't mention this on the About Me slide, but I manage software engineering teams for Cisco. We build web apps for internal and external users. And so we actually have people all over the world, every time zone you can imagine, working in a repo and able to do that safely and efficiently because of the tooling that is built within Git to make that possible. Those commit messages that we talked about, you're not able to push code without a commit message. I guess you can configure a repo to not require them, but nobody I know of ever does. You want to know, give me a comment on what you changed, potentially why you changed it, whatever information I need to know. That goes into basically a running log file of the changes that have happened with your repo. So you can go back, and if, again, the TM something bad happens, you can go back and look and see exactly what changed around those times and figure out why problems cropped up. You also have the ability, and some organizations do this and some don't, but you can park documentation about what you're doing and why, and any pertinent information in the repo directly beside the code, so that your infrastructure engineers don't have to go to another tool to find this. Organizations have varying opinions on whether to do that or not. Some are like, no, everything has to be in Confluence or whatever. Other organizations take a real advantage of this. But because you can do that, now you can version those documentation documents as well, just like you can the actual configurations that we're going to see in a minute. And then lastly, for this particular slide at least, using Git and having everybody working with Git gives you the ability, again, with GitHub, GitLab, and the other hosting, to do what we call pull requests. And so that's the way we get work back into the main code line that we're going to see in just a second. But it gives you the ability then to have your engineers collaborate on these changes, comment on things. You may have an engineer that looks at a pull request of changes that someone is promoting or proposing and says, this is really not the way we want to do this. This doesn't follow our standards, or this is a problem because of X that the original submitter might not have known about. And so again, we take the total experience of our engineers, the ones that are reviewing and commenting on the PR, and use that to catch problems earlier, and then also to make the solutions that we're putting out have much higher quality, because we're sharing knowledge of people that know about whatever the subject is that you're working on. So I mentioned the Git. So one of the primary tooling that Git gives us is the ability to create branches from our main code line. There's a couple of things, and they're very tightly intertwined. It essentially gives you the ability to set up a space to work on new changes. And I'm going to give you an example, kind of a contrived example here in a sec. But imagine you need to do some work, and create a branch. Basically, it's your own space, separate from everything else everybody's doing. And that's automatically managed by Git. It's a fundamental base level idea of what Git's about that allows you to work in there without affecting other people's work and also without their work affecting yours. Gives you a safe space to try stuff, to break stuff that will not, propagate to other people's work. So if we can maybe take a quick little example, imagine Big Boss comes up and says, hey, I need this new set of apps, and here's all the infrastructure that we need, and we need this done ASAP. And Sally and Brenda and Nicholas, I want y'all to go and fix this. So if you imagine the red dot and the line as like a linear timeline, the red dot being here's the state of your cluster right now, and the line being a linear timeline from there. So Sally then goes and creates a branch that's separate from the main code line and starts work on one of the tasks, whatever it is. And then Nicholas started on a task and he's finished, so he commits his code. And Brenda, she finishes her task, and Nicholas finishes another one. And finally, Sally had the big piece of this, right? So she's finished. So everything is done and ready. But you'll notice it's still separate from the main code line that Flux is watching to apply to our cluster. So in the meantime, lots of other stuff has been happening from other teams and other individuals and has been merged back into the main code line as well. None of those red dots you see on the main line on the bottom, none of those changes exist in our branch at this point. So Sally has to then come back and say, all right, we're finished. Now it's time to integrate what's happened since we took this branch. And side note, this could happen at multiple points along the branch. It doesn't always have to happen at the end, but for sake of illustration, that's where we're putting it. Sally brings the changes in, makes sure everything still works. And then now our code is back in all of the setup that is needed for this new set of applications that Big Boss wants is all back into the main code line and ready to be reconciled and patched into whatever environment that is set up for. In the DevOps world, most of this is hidden away in various CI and CD pipelines. It is not in a central place. It's not nearly as easy to collaborate on. If any of you have ever used Bamboo as a CI and CD system, you know the pain of going through their graphical thing and trying to figure out all the graphical widgets to figure out where all of this configuration lives. This puts it all in easily accessible config files that are versioned and are right in your Git repo. So again, I'm not sure how readable that is, but to give you a description, this is a screenshot of my Visual Studio Code looking at a base cluster that has the bootstrap and it has one application that is deployed to it, and that's called pod info. It's a quick little app that just tells you 4 or 5 things about the pod it's running in, and that's all it does. You probably can't see it, but if you can see the little red line around the bottom, you notice I'm in the main branch here. And so if I want to then deploy another app, in this case, Sealed Secrets, which is a really cool package for managing encrypted secrets, so you can put your secrets in the repo with everything else safely because they're encrypted. And then if you look down at the bottom again, I'm no longer in the main branch. I'm off into a separate branch called Sealed Secrets. So I can do whatever work I want to do in here. Nothing will happen with Flux because it's looking at main branch. And I can do whatever testing or whatever. I can potentially set up a local instance of a Minikube or whatever that points to this branch so I can test it completely independently of everything else that's going on my actual cluster. We mentioned pull requests earlier. That's the second main feature that we get from using Git as our documentation and configuration hub for the GitOps way of doing things. So pull requests really, again, invite collaboration between engineers. Because you can request reviews from one or more people, you can basically target either manually or having them automatically assigned, said, I want your opinion. If I'm pushing up a PR, I can say, Dave and Jill and whoever, I want your opinions on what I'm proposing to put into the main code line. And that gives you the ability then to have a second set of eyes, because I don't know how like the architecture engineering world is, but in the software engineering world, if I'm working on something for a long time, sometimes I tend to get glassy-eyed and miss things. Because I know about what this thing's supposed to do. Sometimes I can say, well, that does that, and I miss it. Another set of eyes on it might come in and say, well, that really doesn't do what you want to do. We need to make this change. And we'll see an example of that in a second. It also gives you the opportunity for people to learn on both sides of the PR. The person putting the PR up can learn from potentially other folks that come in with comments as like, this doesn't match our style, or you're going to cause a security hole if you do this, or whatever the case might be. And so they become better informed and better engineers. Sometimes you have people reviewing the PR that they learn from approaches that they see implemented in the PR. So it becomes a really amazing way to share information and share experiences across all ranges of your engineering staff. We mentioned change approvals earlier. This is where that happens, and we'll see an example of that in a minute. Couple of gotchas that I really want to point out. This feedback cycle the feedback must be given and taken in the correct attitude or spirit. The whole idea behind a PR is to make things better. It is not to be ticky-tack or attack people or whatever. If you wind up seeing toxic comments or bullying and stuff in PRs, that has to be addressed and it has to stop. Because if it doesn't, your engineers are not going to want to do the PR process, and your efficiency and everything's going to grind to a halt, and people are just going to hate the way that they do business. So I just, I can't stress that enough, that the idea behind the whole pull request process and review of changes that are going to get pushed to your clusters has to be, from leadership on down, it has to be stressed that this is to be done in the right mindset and the right spirit, and keep an eye on it. So let's look at an example of a PR. So back to that sealed secret screenshot that we had a bit ago, I created a PR, and you may or may not be able to read it, but it says at the top up there is, I want to merge one commit into the main branch from the sealed secrets branch. And so I assigned it to myself, and I requested a review from Mr. Funky Penguin, who, by the way, is a real person, and he's a cool guy. We'll talk about him a little bit more later as well. So that's what it looks like. Nothing's happened yet. I've just made a request. And when I first heard pull request, I thought, that's a weird way to say that. But then as I thought about it, it's basically me requesting you to pull my changes into the main code line. So you can think of it that way. I'm making a request to have my changes pulled into somewhere else, or a pull request. So Mr. Penguin comes along a little bit later, could be tomorrow, because he happens to live in New Zealand, so it probably will be tomorrow. And he says, oh, this looks good, except I think I found a typo. It may be too small here, but the Helm repository name in what I coded, I typed in BITNAM, and my finger's like, oh, NAM, there's supposed to be an E after that. So I typed in the word bit name. Any of you that are familiar with Helm repositories or Bitnami, they maintain all kinds of packages and things. So it should have been BITNAMI. So he actually noticed the typo. He puts a comment on it saying, hey, I think this is wrong. Now, it could be, maybe there is one called bitname, and I'm right, and I can make a comment. It's like, yeah, I see where that could be confusing, but this is actually correct. In this case, he's right. I fat-fingered it. And so he's put a comment on there, and the comment actually then is asking for changes to be made to my pull request before he will approve it. The second red set of text down here that you may or may not be able to read from back there basically says merging this into the main code line is blocked until these requests for changes are addressed. So this goes into not only the peer review piece of him finding a mistake and me not having to figure out later by going through a bunch of log files of why it didn't reconcile and deploy what I wanted it to, but it also then shows the approval process of saying you can't do this until you fix this. And so it's actually effectively blocked. I cannot get this code into the main branch until these things are fixed. So they're very powerful. This is a very simple example. We have had potentially 20, 30 comments as engineers will discuss things and go back and forth on approaches, and all, again, async, because engineers are all over the world. So it becomes a really valuable piece, again, of documentation of the decision making behind when we're going to approve things and when we're going to make changes and go a different way. I mentioned a thing earlier called code owners. So code owners gives you, via a very special config file that we'll look at an example, gives you specific rules of who can make changes or who can approve changes to various parts of your configuration repo. Those can be individual folks. Those can be groups of folks. However it makes sense for your particular organization. When you combine those with what's called branch protection rules, meaning the main branch must have a PR. The PR must be approved by some number of people, 2, 3, whatever your organization decides on, becomes a really powerful approval workflow, all again within GitHub or GitLab or any of the major Git hosting companies. They all support it. So coupled together, it gives you a lot of really fine-grained capabilities. And again, I apologize if that screenshot's not readable, but what happens is basically it takes a top-down approach through the config file, and any later match, so in this particular case, the infrastructure folder and everything underneath it, any changes there has to be approved by the Cloud Ops team in this particular example. If it doesn't find a match down below, it defaults to the very top one, which is the default one, owners, and they will be assigned to the pull request to have to review and approve it before those changes can be merged. There's some pretty advanced things where you can do some, if you have a large team, you can say, well, I need 2 reviewers and do a round robin thing from all of the teammates so that you don't wind up having, 2 or 3 of your people reviewing all the PRs. That's really handy for larger organizations. We've used that very effectively in our teams. So the last thing I want to talk about as far as process goes is rolling back the bad things that happen. So all of this is designed to make sure that we catch errors and misconfigurations as soon as possible, right? But we're human. Things do slip through. It's important to note that this particular rollback is not the same as what happens when you deploy something into Kubernetes and the deployment fails and it rolls back to previous state. That's on cluster. What we're talking about here is in source code, so 2 different sets of ideas. And we do that with a function called git revert. And that allows us to essentially go back to a commit somewhere in the history. Doesn't have to be just one commit back. It can be wherever you decide to point it to, and essentially bring the current version to there. So there's a timeline with some commits like we saw earlier. We figure out that the very last one is a bad commit, and we do a git revert to the one before that. So what that does is under the hood, it does a lot of inverse changes. So it knows what all changes have happened during the bad commit, and so it basically makes the inverse of all those changes. Was this line added? Okay, in the git revert, this line will be removed. This word, etc. So one of the things that is important to note, though, you'll notice in the diagram, we don't remove the bad commit. The bad commit's still there. Why? Maybe we want to do a post-mortem after we get this fixed of how this happened. All of that bad config data, that bad commit with the errors in the config data is still in there for us to review, go over, and learn from. One of the things that we have, I guess we didn't have this originally. It's come along in the last, several years, but it's like default for us now. there's the idea of squashing a PR. And that sounds bad on the surface, but if you remember our branching diagram that had all of those commits on the branch, we don't want all those individual commits to come to our main branch, because that causes a bunch of churn in our reconciliation process in Flux. So what we'll do is when we merge that last commit on the branch back into main branch, we actually will squash all of the commits into one commit, and it concatenates all of the commit messages into one commit message. That makes it really easy on your main line to go, okay, all this happened, this happened, this happened. And so essentially every branch of work, that whether it's an individual's branch or whether it's a team branch, gets squashed down into one commit when it hits the main code line. And so what you then wind up having is a series of commits that map to bodies of work, whether that's a one person's body of work or whether that is a team. It makes it a lot easier to go back and look and see what happened. And then, of course, the next reconcile comes along and applies your good configuration, Bob's your uncle, and you're back in business. So there's a couple of anti-patterns that I want to point out and pitfalls to avoid that I and some of my other friends that are in doing the GitOps thing have run across. Don't use long-lived branches. Now, what do I mean by long-lived branches? Don't have a separate branch for dev and a separate branch for staging that just continue, into the future. Your branches should be fairly short and then get merged back to main. You might think initially this would be a really good idea, but it becomes very difficult to move configuration between environments when you do that, because you may have one team that pushes something into the dev branch and another team pushes something, and you want only one of those to go to staging. It's really difficult to pick all those out, and you're going to miss something and break something. So don't do that. Don't fall for the temptation. This should not have to be said, but don't put unencrypted secrets in your repos. Use sealed secrets or something analogous to that. Don't mix your infrastructure with application deployment. If you need network policies and all that stuff, do a PR for those, and then do a PR for deploying your application separately. Makes it a lot easier to debug later if they're not all mixed together. Don't deploy resources by hand with kubectl. If you're got Flux in the mix, you're going to confuse Flux and just make all kinds of problems. Trust your infrastructure as code process. Go through that process and let it handle the deployments. We talked about mono repo performance. As your cluster size grows, I'll just point that again. Configure your permissions on your repos fairly early and get that in place. So next steps. I'm at the point in my journey right now with Flux and Kubernetes where I'm looking forward to getting a little bit more into the do not repeat yourself arena. With overlays, you could actually set up it's kind of like snippets, things that are bits of configuration that are included in multiple places. So you don't have to copy things between dev and production and whatever environments. This is something I'm still learning about. I was doing some reading about it last week in research, and I'm like, this looks really good. One of the things it does is it gives you a hierarchical set of build steps that you can understand all the different things that have to happen to get to your end state of how your Kubernetes cluster is going to be configured. The downside is it's a little bit larger of a mental model. You can't just look in one place and figure it all out. And therefore, sometimes it's not as easy for less experienced folks. So take all of the above and understand what approach is good for your particular organization. Do some more research. Don't try to eat the entire elephant all at once. You need to measure it too. Figure out what measurement metrics that make sense for your org. It could be decrease in number of trouble tickets for infrastructure related problems. It could be speed at which you can deploy new things. There's a lot of ways to measure stuff. I'll take my manager hat off for a second and get off of that soapbox. And then never stop learning. This stuff moves very quickly, and it takes keeping up with it. So thank you for your time. A couple of acknowledgements. I told you the Funky Penguin was a real person, Mr. David Young in New Zealand. I've learned so much working with him in the self-hosting world the last 4 years. The Flux docs are wonderful. And then a gentleman named Christian Hernandez, who at the time worked for Red Hat, wrote a book called The Path to GitOps that has some wonderful information in it. I've learned a ton. Thank you all. I'm out of time, almost to the second. That's almost perfect. I hope you all learned a little bit. Thank you much, and enjoy the rest of your evening.